Hi, so in this example, we're going to conduct a hypothesis test regarding two dependent population means. So because they're going to be dependent sampling, or in other words, match pair, we will have to use the dependent sampling technique. So in this case, it's a common belief that SUVs are safer than cars. In a collision, does an SUV sustain less damage, cost of repair than a car? So here are the types of cars we have, and here's the SUV damage, and here's the car damage. So in a collision, does this car CRV into a Honda Civic? So if a Honda CRV crashes into a Honda Civic, so that's why they're dependent, because this car damage here is dependent on the SUV damage and vice versa if they crash into each other, right? So we're going to test this claim whether or not that the SUV can sustain less damage than a car. So we're going to test the claim at the 0.1 level of significance. Because it's a two sample proportion and the sample sizes are less than 30, then we have to conduct normal probability plots and a box plot to make sure that there are no outliers. And note that in the problem itself, it did indicate that a normal probability plot indicated that the population is normal and the box plot indicated no outliers. So in fact, they gave us that preliminary information, so we're allowed to go right into the test. So let's go ahead and express the null and alternative. So because we're dealing with the difference, we're going to subtract mu sub 2 from mu sub 1. And that means mu sub 1 will represent the SUV and mu sub 2 will be the car. So right away we know that there is no difference, right? Or there's going to be a difference. And in fact, the SUV will be less cost of repair than a regular car. So this means that this result is going to be a left tail test, right? Because the SUV is mu sub 1 and that's going to be less than mu sub 2, then we have it, okay, then that difference has to be a left tail test. So the level of significance is going to be given to us at 0.1. So we'll go ahead and put that. The test statistic for a sample mean, in this case, remember that if we are doing just the differences, that means that we are doing a one sample t-test on the differences, because recall with dependent sampling, we always look at the difference. Like if we were doing the car damages, we would say, oh wow, that one looks a lot worse than that one. Well, that means that we're looking at the difference in damage, right? So this means we're going to have not a Z, but a T, and then we can get this from the calculator. So the first thing you'll want to do is go to your calculator and go ahead and go to Stat and go to Edit and enter your data in List 1 and List 2. So List 1 should match mu sub 1, which was SUV damage, and mu sub 2 should be List 2, which is the car damage. So my List 1, you'll notice, looks like the SUV damage, and L2 looks like my car damage in dollars, right? So now move the cursor over to List 3, highlight it List 3 so it's black and highlighted. I'll move it down and up, right? So make sure you're up here with L3 highlighted. Now let's go ahead and find these differences. Because I took mu sub 1 minus mu sub 2, I'm going to take list sub 1 and minus list sub 2. So I'm going to do second 1, L1, minus list 2, second 2, which gives me L2. Now hit enter and I'll get all the differences. And don't worry about all those negatives. We just need those just to run the test. So the next step I would do is go to Stat, go to Test, and because we're doing a dependent hypothesis with dependent means hypothesis test, we actually use a one sample t-test because we're only testing against the difference. And so we have data in a list where our list that we want to run is not L1, not L2, but the differences, and that was L3. So second 3 will get L3 in there. And we had a left tail test, right? So left tail, and just go ahead and calculate. So the t-test statistic is given to us rounded to 3 decimal places is negative 2.685, and the p-value is 0.0181. Since our alpha was 0.1 and our p-value was 0.01, our p-value is significantly lower than our alpha, and that means we would have to reject the null. And if we reject the null, that means that we accept the alternative, and that means that we can go ahead and say that there is sufficient evidence to support the claim that SUVs sustain less damage than a car collision, because our claim was our alternative hypothesis. And if I go ahead and submit this, you'll see that every part was correct. So just make sure that when you have two dependent samples, or two samples that are dependent, you would run a one sample t-test on the differences, and that differences should be a separate list in your calculator.